Dear students, good morning. I am Professor Ashok Suryavanshi. Today I will be explaining about the course awareness session on Power Electronics Elective 1. So let us start. Uh, because of the OBS studio, there may be some noise in the video. So please tolerate that. So what is power electronics? So everybody knows that power is very essential nowadays. Everybody requires the power, even if it is a farmer, they need the power for the switching on the pumps, right? Everything works on the mobile nowadays. So power is required everywhere. So what is power electronics? Power electronics is application of electronics, that is solid state devices and circuits. Solid state devices means semiconductor devices, and these semiconductor devices are used in those power electronic circuits to convert the power from one form of the power into another form of power, that is conversion and control of power. So power electronics is used to change the characteristics of electric power. That means whatever input power you are having, AC power or DC power, that can be converted into the required power as per the load, as per the application. For example, if your load is DC motor and source is battery, then you need to convert fixed DC into variable DC. If your input is source is battery and load is AC motor, then you have to convert that DC power into AC power, something like that. So it is all about the conversion and control of power using electronics, that is solid state devices, semiconductor devices, right? Like power BJT, power diode, SCRs, MOSFETs, IGBTs, etc. So in case of the power electronics, okay, so there is a electrical power converter which converts input power into output power using the control input. So there are two types of powers, DC power and AC power. So depending upon the requirement, say for your input is AC and output required is DC, so you convert AC to DC, that is called as a rectifier. Your input is AC, output required is AC, so it is AC to AC converter, power converter. Similarly, if your input is DC, output required is DC, variable DC, then it is called DC chopper, DC to DC converter. And when your input is DC, output required is AC, then it is DC to AC converter, that is inverter. So in case of the power electronics, we have the source input power which we have to convert into the required power like AC or DC depending upon the load and requirement, and then that is done by the power converter using the controller, because these power MOSFETs, IGBTs, SCRs, they need to be switched on and off, so they need to control. So we can use the controller like discrete controller or maybe digital controllers like microcontroller, microprocessor, DSP controller, etc. So source can be electric utility, like any kind of the energy source, like your DC source, AC source, or maybe from solar energy, wind energy, like that, batteries, right? Or it can be any power converter also, or any other electrical source. Or load can be electric motor, AC motor or DC motor. It can be light load, or it can be heating load, or it can be any other power converter. So this is power electronics is actually multidisciplinary course. There are various applications of this power electronics, like in industrial, transportation, utility systems, power supplies for all kind of electronic equipment, residential and home appliances, space technology, and other applications. So if you look at the industrial applications, there are various applications like motor drives, electric welding, electrolysis, lighting, etc. In case of transportation application, majorly it is electric vehicles. In electric vehicles, automotive electronics, trains and locomotives, etc. In case of utility system applications, energy storage systems, supplement energy sources like wind, photovoltaic, fuel cells, high voltage DC transmission. In case of power supplies for electronic equipment like in telecommunications, computers, laptop requires the electronic power supply. Office equipments, electronic instruments which are used in the industry or maybe in the laboratory, academic laboratory. Then portable and mobile electronics, so everywhere we require the power supply. Then residential and home appliances like lighting, heating, air conditioning, refrigeration, cooking, cleaning, entertaining, everywhere the power electronics is required. Entertaining means in television and etc. Application in space technology, so in space technology, spaceship requires the power supply system, satellite requires the power supply system, space vehicle requires the power supply system. Other applications like environmental engineering or nuclear reactor control, power systems for particle accelerators, etc. So there are variety of the applications where power electronics is required. For example, here it is automotive electronics, electric vehicles, then energy storage, then battery chargers, right? Switching mode power supply, SMPS, uninterrupted power supply, UPS, power supply generation from solar, fuel and wind. So everywhere this power electronics is required actually. So this is simple example of the application of power electronics, where we can see the generation of power from different sources and then transmission, distribution. So here also power electronics is required. In high voltage DC transmission, we require to convert AC to DC and vice versa, DC to AC. Again, in case of the photovoltaic, that means solar energy or wind energy, between the utility grid and the solar cells, we require the converters, DC to DC converter and DC to AC converter. In electric vehicles, you can see the block diagram. The basic important block here is a power converter, which converts one form of power into another form of power. Like if it is input is battery and electric motor is DC, we require DC to DC converter. If the electric motor is AC, we require DC to AC converter. So in all electric vehicle, you will find one important block, that is power electronics controller, where you can use a DC to DC converter or DC to AC converter, which is nothing but the power electronics converter. In case of the hybrid vehicle also, electric vehicles, we require this DC to DC or DC to AC. In case of the plug-in hybrid electric vehicles also, we require DC to DC or DC to AC. In case of the hydrogen fuel cell vehicles also, we require this DC to DC or DC to AC converters. Now let us talk about quickly syllabus. So power electronics elective 1, it is having course theory as well as laboratory. In theory, you are having the 2 credit course, 2 lectures per week, 20 marks for internal evaluation IE1, IE2, which will be activity based, and then MT 30 marks, ET 50 marks, total 100 marks. Basic knowledge required for this course is those students who are having good knowledge of electrical and electronics engineering, electronic devices and circuits, fundamental of mathematics, network analysis, analog integrated circuits, they can opt for this particular course. These are the objectives, these are the outcomes of this course. The unit number 1 is completely devoted for the power devices like SCR, silicon control rectifier, power MOSFET, IGBT. So here we learn basic fundamentals of the devices, power devices, which are used in the power converters. Second unit is AC to DC power converter. Third one is DC to AC power converter, and here we are going to study the applications also of these power converters. And the fourth unit is dedicated to DC to DC and AC to AC power converters and their applications. So total 30 hours course. These are the textbooks and reference books which are available in the library. Even the student can go for the NPTEL course. As far as the lab course is concerned, it is 1 credit course, 2 hours practical per week, 25 marks term work, 25 marks practical examination, so total 50 marks. Objectives, these are outcomes. These are the practicals. We have divided into 3 categories. Group A on power device characteristics, where students have to do the VI characters of ACR, and from the VI characters of power MOSFET and VI characters of IGBT, students can do any one of them because these two falls under the transistor category. From category 2, that is group B, students have to perform experiment number 4, 5, 6, 7, because these are the experiment based on the power converters. So fourth one is AC to DC, fifth one is DC to AC, sixth one is DC to DC, and seventh one is AC to AC. So this can be performed on trainer kits which are available in the laboratory, and the student can perform using the simulation software, that is PSIM, Power Electronics Simulator, which is purchased by us. Then from the third category, group C category, student can perform any two. These are the application based. So student can perform either SMPS or UPS. Student can perform either speed control of DC motor or AC motor. Student can perform design and implementation of solar cell operated emergency lighting system. So from this 2, from this 4, 6, and from this 2, 8. So total 8 experiment students have to perform. Then again, it is recommended to arrange a visit to solar power generation plant or electric vehicle manufacturing plant, so that students can get in-depth knowledge about the power electronic converters and the power devices. So as students are learning basic electrical and electronics engineering first year, electronics device and circuits in second year, network analysis or theory in second year, analog integrated circuit in second year. Now student can opt for the power electronics elective 1 course, so that in line with these courses, student can further choose energy harvesting and management elective 3 in TY second semester, energy management system elective 4th TY second semester. Then further, student can go for honors course in TY BTech semester 1, that is energy storage system for electric vehicles. Even students can go for EV motor drives and controllers for electric vehicles, right? And then EV system design and architecture honor course. So last two, ninth and 10th is 8th, 9th and 10th. These are the honor courses which student can opt for, and then once they can go study all these courses, student can get placed in KP Technology, because this is the one of the company which is associated with uh, PCCV for the placement. Many our alumni are working in the KP Technologies. DB Electronics, one of the most popular company in the Pune in polytronics. Likewise, there are 70 companies in the Pune of small scale, medium scale, and large scale. Even Tata Motors, Mahindra and Mahindra, everybody knows these companies are also, they are working in electric vehicles. And at international level, global level, if you look at ABB, Texas Instruments, Infineon, Analog Devices, Toshiba, Delta Electronics, these are the companies which are Mitsubishi Electric, they are working in the power electronics. Thank you for patient listening.